This function is h of x. It's defined to be equal to x squared plus 2x whenever the x values are less than or equal to negative 1. Now, if the x values are negative 1, less than x, less than or equal to positive 1, then the function is defined to be equal to h of x equals x. And for x values that are greater than 1, the function is defined to be equal to h of x equals positive 1. Then we're asked to find part A, h of negative 3, part B, h of 1/2, part C, h of 1, and part D, h of 2. So we're looking for these y partners to x equal these negative 3, 1/2, 1, and 2 in the set x h function. Now the thing is, you have to decide which of those three definitions you're going to use. So for the first one, h of negative 3, we look at the choices. Is our x value greater than 1? No, negative 3 is not greater than 1. Is it between negative 1 and 1? No, negative 3 is not between negative 1 and 1. Is it less than or equal to negative 1? Yes, it is. That puts it in the top definition. Top definition says you take the negative 3 and you square it plus 2 times the negative 3. You square the negative 3, you get 9 minus 6. So your answer is 3. And that definition came from the top definition since x was less than or equal to negative 1. Next, we're looking for h of 1/2. Now, which of those three definitions can we use when we have h equal 1/2? Well, 1/2 is between negative 1 and 1, so we're going to use the second definition. H of x is equal to x. So h of 1/2 is equal to 1/2, using the second definition. Next, h of 1. Now, h of 1, our x value, is equal to 1. So which of the definitions can we use? We have to use the middle definition because that's the one for x less than or equal to 1. See, there is an equal portion in that inequality sign, so we must use the second definition. We couldn't use the last one because that's for values of x greater than 1, not greater than or equal to. All right, so we see that using that second definition, h of x equals x, h of 1 is equal to 1. And that's using our second definition. And finally, we have h of 2. Now, x equals 2 for part D, and 2 is an x value that's greater than 1, so that demands that we use the last definition. And that definition says for x values greater than 1, h of x is just equal exactly to negative 1. All right, our 2 is greater than 1, so h of 2 is equal exactly to negative 1. That's using the third definition. So the value for the x makes the decision about which definition we use to evaluate our function h.